Please go ahead. We are live.
Can we start?
Yes, ma'am.
Yeah. I hope everybody is able to hear me. Good
Yep.
afternoon, ladies and gentlemen. I'm Joint Director and Head Energy at ASSOCHAM. For the first time, may I briefly introduce our chamber chair. ASSOCHAM is one of in the country. In 1920, it has a legacy of this was the chamber in the Western President. Its ambit. We thus have the largest the which are all members the league membership of ASSOCHAM. ASSOCHAM represents thermal, distribution, transmission, hydro, and renewable verticals. Today's event is being organized under the auspices of Renewable Energy Council, which is headed by Sri Jayant Parimal, CEO, Adani Green Energy, the largest in the renewable energy space. We also have with us Mr. Saurabh Singhal, Director, Octus Advisors, Energy Consulting Partners. They've been associated.
Kavita, we are unable to hear you.
Hello. Hello, Kavita. Somehow we missed you in the last lines. Anyway, maybe your connection was a little poor. So, ladies and gentlemen, welcome to this webinar on battery storage technologies roadmap for India. And we in our renewable energy subgroup in ASSOCHAM, we are very happy to welcome all of you in this webinar. It is a very, very relevant webinar. I cordially welcome all the panelists as well as the participants. You will appreciate that battery energy storage is providing wide array of technological approaches for managing power supply and creating a more resilient energy infrastructure. Renewable is one of the most focus area for this government. There is already a timeline, 175 gigawatt we want to do by 2022. And ultimately we want to take it to 450 gigawatt and maybe more also. And time and again, the government has committed towards that. Because of the intermittent nature of the renewable power, both solar as well as wind, it is necessary that as the grid renewable penetration in the grid increases, you have to manage the grid far well, and the conventional methods cannot be sufficient. And battery storage comes in very handy in that, and it also is able to provide all kind of ancillary services. And therefore, BESS solutions are needed for a seamless and reliable transition into significantly higher penetration of renewable. That includes peak load sharing, other ancillary services, etc. And to promote Atmanirbhar Bharat Abhiyan also, the government is trying to give preference to the domestic manufacturers. The Niti Aayog has also sought a cabinet approval for this proposal to build 10 large facilities in India for producing lithium-ion batteries, etc., both for storage purposes as well as for electric vehicle purposes. The panel today will deliberate on all these points, and to take forward the discussion and coordinate it well, we have invited Mr. Saurav Singhal, who is the director of Octus Advisors, who are energy sector consulting partners of ASSOCHAM. So I would now like to invite Mr. Saurav Singhal to coordinate the panel discussion and the webinar and take it forward. Mr. Saurav Singhal.
Thank you, Mr. Parimal. It's a pleasure to be a part of this panel today. And as you rightly said, it is possibly the most relevant from an energy self-sufficiency perspective for the country. So it's a great discussion that I'm anticipating. We have an eminent panel. Before I go and introduce the panel, let me just briefly highlight the objectives of this discussion. So we would like to first understand various technologies strategies available for energy storage and their relative positioning with respect to cost and efficiency. We would also like to understand, listen the panelists on various storage applications, right? Electricity, EV, relevant to the country, their benefits, and what solutions are required to ensure the expected growth in demand over the next few years that is met. We will discuss and try and reach solutions on policy framework and changes required for faster adoption of storage systems for critical applications. And finally, we'll also want to discuss some bit of domestic manufacturing ecosystem and what business models and strategies / policies are required for the growth of domestic manufacturing ecosystem. Right. So that is broadly the areas that we will cover today. We have with us several leaders of this ecosystem and this space in the country. Of course, Mr. Parimal himself is going to be a part of the panel. He needs no introduction. As Kavita said, he heads the Adani Group's renewable energy business. He has a vast experience in renewable projects from a developer standpoint, as well as from a module manufacturer standpoint. So he will help us understand the critical aspects of large-scale adoption of battery storage technology. We have Mr. Sohinder Gill. He's the CEO of Hero Electric Vehicles Private Limited. He's also, so Hero Electric is, as you know, is India's largest electric two-wheeler company. So he has a rich experience in understanding the EV ecosystem and the battery implications from an EV standpoint. He's also the Director General of Society of Manufacturers of Electric Vehicles, which has played a pivotal role in supporting the EV industry. So welcome, Mr. Gill.
Thank you.
We have with us Dr. Rahul Valavarkar. He's the president of India Energy Storage Alliance and also the president and MD of Customized Energy Solutions India Limited. Under his leadership, Customized Energy Solutions India Limited has become a thought leader in the areas of storage, renewables, demand response, and smart grid technologies. He is the one who founded India Energy Storage Alliance in 2012 and has been a president since. We believe his experience with emerging technologies like energy storage that will give us today, critical insights into current technologies and upcoming technologies for battery storage. So, Mr. Valavarkar, welcome to this panel. We also have Mr. Kushal Nandan. He's the co-founder and president of SunSource Energy. He has 20 years of experience in developing multiple large-scale, megawatt-scale kind of solar energy projects. A lot of experience in rooftop and off-grid. SunSource leadership has scaled up capability to take on extremely complex projects and delivered more than 150 solar power plants across Asia. So we believe his vast experience as a solar developer will help us get a perspective on applications of battery storage technologies when it comes to off-grid power. Welcome, Mr. Nandan. We look forward to your inputs there.
Thank you.
We are we're joined by Mr. Kulkarni. He's the Vice President Innovations at SB Energy, SoftBank Energy. As you all know, SoftBank is a large investor in Indian ecosystem, and within SoftBank investment, SB Energy plays a large role in renewable space. He's from an SB standpoint, he's at the forefront of innovation in power, and he'll help us understand various upcoming technologies in the RE sector. Welcome, Mr. Kulkarni. We also have Mr. Rashi Gupta. I'm not sure she's online. She's a managing director. She's supposed to be a part of the panel. I think she'll be joining in the next few minutes. Mr. Rashi Gupta.
I'm here. I'm here.
Hi, Rashi. Can you hear me? Great.
Yes, I can hear you. Thank you.
Great. Welcome. So, Mr. Rashi is the managing director of Vision Mechatronics. They are the pioneers of manufacturing of advanced lithium batteries in the country. She's also a committee member of Bureau of Indian Standards for Batteries, Energy Storage, and E-Mobility. Her experience with lithium-ion battery manufacturing, we get a perspective on current challenges and future expectations and solutions for battery manufacturing in the country. Welcome, Rashi. We're joined by Mr. Jasmeet Singh Kalsi. He's the director of Manikaran Lithium Private Limited. So Manikaran Lithium Private Limited is possibly going to be in the forefront of manufacture of and refining of lithium in the country. He has large 20 years of experience in energy sector and in infrastructure domain. And it'll be interesting to see this new foray in the Indian lithium refining market. So welcome, Mr. Kalsi. Look forward to hearing inputs from you on lithium manufacturing.
Thank you, Saurabh. Thank you so much.
We are also Mr. Abhishek Goyal is a director at Global Infrastructure Partners. Globally, GIP is one of the largest investors in renewables. They have more than 26 gigawatts in their portfolio, including the world's largest offshore wind farm. In India, Mr. Abhishek Goyal leads the platform called Vector Energy, which operates 650 megawatts of renewable energy and is growing extremely fast. We'll get some perspective and insights on how a large investor in this space, from a developer standpoint, is thinking about battery solutions going forward. Welcome, Abhishek. I'm not sure if Nishit Mehta has joined.
Yeah, I'm here. I'm here, Saurabh.
Hi, Mr. Mehta.
Yeah.
So, Mr. Nishit Mehta is the SVP of Corporate Strategy and Governance at Sterlite Power. Sterlite Power as you all know, is a leading private developer of transmission assets in the country, and also overseas like Brazil. Nishit is a veteran of the electricity industry with past experiences in multiple nations, and has previously co-founded a battery startup called Synode Systems, which is now Nanograph Corporation in the US. So we look forward to insights on value additions with grid scale large battery storage solutions. Welcome, Nishit.
Thanks, Saurabh.
Great. So, ladies and gentlemen, let's start. I would actually like to begin with the perspective from Rahul, and I'd like to begin at a slightly higher level and talk about various battery storage technologies in the market today. Right, and we all know, right, there are different technologies, and any market over the years typically develops different standards and different technologies together for a certain period of time till the time they converge. So we would like to hear, Mr. Rahul, your views on what are these various technologies, battery storage technologies in the market today. How are these technologies evolving from a pricing and efficiency standpoint? Do we see any convergence in the near future over maybe next 5 to 10 years in terms of their application, in terms of their evolution, and therefore, do you see countries and investors gravitating towards specific technologies, globally and then in India also? And why do you think that is going to be?
Thank you, Saurabh. And first of all, let me thank ASSOCHAM and especially Kavita ji for inviting IESA to partner with ASSOCHAM for this initiative and inviting us to be part of this panel. In terms of the batteries, there are right now more than sort of 12 key families of electrochemical batteries which are commercially available. Of these, some have been around for more than 100 years, like lead acid batteries or even nickel-based batteries, sodium-based batteries have been around for multiple decades. In terms of the commercial applications for grid scale renewables, we are seeing in terms of distributed solar, still lead acid batteries are being used along with rooftop solar by many consumers because they are used to it. They are used to having lead acid batteries as part of the UPS or inverter systems. But in terms of the fastest growing market, lithium ion family of batteries is definitely catching up. Within lithium ion batteries, there are different subsets such as lithium iron phosphate, lithium nickel manganese cobalt. So depending on the application, different chemistries may be applicable. There are also other technologies which are being seen as suitable for longer duration applications such as flow batteries, where again there are almost around 8 subfamilies within flow batteries, but the dominant flow battery chemistries include vanadium redox and zinc bromide chemistry. So both these chemistries are seen as a potential technologies which can be used for applications for more than 6 hours. So lithium-ion batteries are seen for typically applications for around anything from 30 minutes to up to 4 to 6 hours. And beyond 6 years, there are a number of companies who are trying to commercialize and scale up manufacturing of these alternate chemistries. There is also a lot of work happening in some new forms of chemistries where people are really looking at cheaper batteries, which can also be used for multiple day kind of a storage. So these are right now in early stage of commercialization, but if you're looking at like a next 10-year window, then some of these chemistries may also come in. There are a lot of prominent venture investors who are betting on some of these technologies where they are looking at going to materials like iron or others, which may be like much more abundant and may not have any supply constraint. So there is a lot of innovation happening in this space. In the Indian context, a lot of time we are focusing on only capital cost as a key decision if the batteries will be applicable or not. But when you look at it from the application point of view, there are multiple parameters such as cycle life, energy density, which will determine the footprint, size of the technology, the charge discharge rate. So all these parameters together. So when we evaluate technologies for different applications, we evaluate them on 8 different parameters, which includes also parameters like safety, which should be very crucial. And then according to that, right technology can be chosen. The way we are seeing right now in the world, there is definitely lithium-ion battery chemistries are getting a lot of attention. Right now, there is somewhere around 350 gigawatt hour of annual manufacturing capacity, which is already getting operational as of end of this year, which is both applications for mobility as well as for stationary storage. But already there are announcements which put the lithium-ion battery manufacturing for 2025 at around 1500 gigawatt hour. Even India is looking at setting up around 50 gigawatt hour of advanced chemistry cell manufacturing by that time. So lithium-ion battery chemistries are definitely taking lead, but I wouldn't rule out other chemistries. We as a India Energy Storage Alliance have a very active program in supporting startups and early stage companies where we are helping all these other chemistries as well.
So, Mr. Rahul, do you see, like I said, right? So, and you rightly mentioned the capital cost is one of the major factors, is the headline kind of a cost that goes into determining whether the batteries are viable or not. But of course, there's a life cycle cost. And I'll go to Mr. Parimal to discuss that. But as you know, the costs have been dramatically coming down, right? And especially the installation cost, the capital cost is coming down. And we believe it is coming down faster than it was expected 2 years back, maybe. So right, so is and different types of chemistries, they have different costs, upfront costs, and all of them are coming down. So the question here is: are we looking at a convergence in the future, or do you think they will continue to be multiple, chemistries evolving together for different applications?
So we see there will be multiple chemistries will continue to evolve because again, now when you look at only the capital cost, then some technologies definitely are becoming more dominant, especially the lithium-ion battery chemistries. But when you consider the levelized cost or the total cost of ownership, there are again certain applications where, for example, utilities are saying that they would prefer technologies which can have 25, 30 year of life. And there, in fact, there are even beyond electrochemical batteries, there are even chemistries based on gravity-based storage, not just pumped hydro, but other forms of gravity-based storage, thermal storage or electrochemical, electrothermal storage. So multiple such opportunities are being seen for those. So we think there will be certain dominant chemistries, like for example, lead acid batteries have dominated the world for more than 150 years. So similarly, at least next 20 years, lithium-ion batteries or newer versions of lithium-ion batteries, such as solid-state batteries or lithium-sulfur batteries, which are again part of the lithium-ion chemistry, those will continue to dominate. But there are specific applications where metal layer batteries or other chemistry of batteries like sodium-based batteries, they may also find applications.
I see. So coming back to the question of levelized cost of energy, right? Mr. Parimal, I would like to know and understand from you as a developer, you know that there's been a recent bid where the government has asked for sort of an RTC power from renewable energy sources. And in that case, obviously a key role will be played by battery strategies and battery technologies. And we've seen the levelized cost of energy is still very, very high, right? We've got the bid of around 6 rupees to 7 rupees. So as a developer, Mr. Parimal, what do you think, when will you see or when do you expect to see over the next few years, the battery prices as a levelized cost of energy, battery prices going towards closer to, let's say, a RTC thermal power of, let's say, 4 rupees 30 paisa? Are we getting close to that? Are we moving in that direction? How many years will it take for us to say, okay, now renewable energy plus storage is almost at par without any incentives, almost at par with let's say a base load thermal energy?
Hi, Rahul. Now let us try to understand what does that RTC mean. Actually, there are various connotations to RTC. The extreme variety of RTC is that as soon as I press my switch, the light should get switched on or fan should get switched on. So on demand, okay? So that is the most difficult kind of thing, RTC, which is very difficult for any renewable power plant married with storage to give. So this means that you will have to have too much of storage to take care of all kind of variabilities in the weather. So if you are asking for that kind of RTC, the storage cost will go dramatically up, and therefore those kind of numbers which you said is there 6 rupees, 7 rupees, etc. If it is another kind of RTC where I give what I promise, where this means that whatever I have scheduled, I will definitely give you. So that is a separate kind of an RTC. There, you need slightly lower storage. So there the cost will be lower. Ultimately, the cost of RTC power is nothing but weighted average cost of direct power renewable which is going in the grid and plus the power which passes through the storage device. The storage device, the power which passes through storage device may cost you significantly higher, maybe at least 10, 11 cents or something of that kind. So art is how to balance the ratio between the power which is going directly without any storage device and what is going through storage device. So this depends on the bid. Some of the bid conditions are very tough where it is practically on-demand kind of thing. I press the button when I ask you, you must generate, which coal-fired power plants can do easily or gas-fired power plant can do easily. In case of storage-based renewable power plants, you have to have a lot of storage. So right now, even if you take $250 per kWh all in cost plus taxes, now taxes are very high. You have high import duty and you have 18% GST. So the whole thing has, if you are marrying it with solar, you will have to bring down the GST to 5%, similar to what is there in the case of solar. And similarly, the import duty has to be brought down significantly. So unless these two things are brought down and the cost of the storage technology itself comes down significantly from say $250 basic to say $150 basic, I don't think on-demand RTC will be viable on a IPP kind of a stuff. But some different variety of RTC, yes.
Yeah, no, you're right. So we do see, and Mr. Walwalkar, correct me if I'm wrong, we do see prices moving towards more of $170, $180, in the near future, or maybe, even currently some of the sourcing that I have come across, they are around for 160, 170. So are we likely to hit these prices anytime soon?
So actually, I would like to take the discussion on a different direction. I think this is something, I think these price points and this expectation is actually killing the industry, or it is preventing industries to take off. Right now in India, we have more than 80, 90 gigawatt of diesel generators installed. Again, not all of them are operating continuously, but there is somewhere around 5 to 10% of those diesel generators are being used more than 1,000 hours, where it is costing customers anywhere from 14 rupees to 18 rupees per kilowatt hour. So just the expectation that we need to have RE plus storage coming at 4 rupees or below 4 rupees is itself is not required. And as a load weighted, the contract which was won by Renew for with SECI tender, that has a load weighted price for 6-hour guaranteed peak price deliverability of 4 rupee 30 paise. So the price is already very well acceptable. The other side is that when you look at these prices, one of the things which will happen is we anticipate a big adoption happening on the behind the meter side. Because right now, if you see, even I think maybe the residential customers, at least in Maharashtra, who are staying home and consuming more than 500 units per month, are paying a tariff of more than 10 rupees to MSEB. Similarly, especially commercial industrial customers are paying that price. So even if at a rooftop solar plus storage comes at 6 rupees, 7 rupees, that is something which is a straight saving right now for the customer. So I don't think we need to wait for any more price reductions because again, as we have seen with solar, the cost reduction of solar has not happened just because of the panel prices have come down. 10 years back, the share of panel prices versus the rest of the system cost was also different. Also, the way the project optimization happens, it is different. So I think we are way late right now. We need to actually start getting these deployments, and as the deployment scales up, the prices will continue to come down. I'm not saying that prices will not come down. That trend is there. But I think we have already, maybe 2 years back, reached a price parity where we should be deploying a lot more such hybrid projects in India than what we have been doing right now. For example, last 5 years, we are talking about Andaman Nicobar with 70 megawatt of diesel generators powering entire island and polluting with an average cost of around 28 to 30 rupee per kilowatt hour. Now, even 5 years back with the storage price and solar price, what it was cost effective to replace those diesel generators. So we need to focus on these type of applications and do it rather than waiting for prices to come down for everyone.
It's excellent. So I think this sets up very nicely for, and you're right. I think the discussion on price is critical. However, it's not the only driving point. So I would like to ask then, Mr. Nishit from Sterlite Power. There are, like Rahul said, right, there are various applications where the prices are actually feasible even now, right? So what are these various applications from a large scale grid storage standpoint that you see today and evolving today globally and evolving slowly in India as well? And, how relevant the global applications are in an Indian context. We have a specific grid, we have our own challenges in the grid and own specificity of the grid. So in those kinds of, in that environment, how relevant and how, critical are these applications? That is one. And we would also like to hear from you, what are the challenges that we are facing in this large scale adoption? We've not really seen a large scale adoption of storage technologies in the grid. You are in the forefront. You've submitted a grid in the US. So tell us, what do you feel are the challenges of this large scale adoption in the grid storage?
Yeah, thanks, Saurabh. Can you hear me?
Yes, we can hear you.
Great. Yeah, so I would kind of start off by saying that I'll restrict my answer to the grid scale applications because, as Rahul mentioned, there are a number of applications beyond the grid as well and closer to the consumer. And generally speaking, the value of the application goes on increasing the closer and closer you get to the customer. So I'll kind of restrict my answer to grid scale applications. If you look at grid scale applications of energy storage, there's broadly three categories of applications. And these categories basically vary by duration of storage required and the rate at which the storage needs to be charged or discharged. And I'll go by value in terms of which are the most immediate applications that make the most immediate sense commercially, where the value is large, and move on to the others where the value might be a little lower per unit, but the volume required will be pretty high. So the first application that comes to mind is frequency regulation. And this is something that, if you see globally as well, is the first application that gets addressed and saturated in any market for energy storage. And this comes from, as everybody understands, the frequency deviation that happens in the grid. And in India, especially, this is a concern with the average monthly FDI in India being outside the IEGC band for more than 20% of the time consistently. And on some days, it is outside of the band for more than 50% of the 24 hours in a day, or 96 time blocks. So this is a pressing immediate concern for the Indian grid. Today, it is addressed in not directly through a frequency regulation market, which is under the works, but indirectly through DSM, etc., where we address it through these different methods. So if we consider the frequency regulation kind of application, that itself is a 2 to 3 gigawatt requirement of battery energy storage capacity or any energy storage capacity that could fulfill these requirements. Once we move beyond frequency regulation, next most immediate requirement would be from a ramping perspective, especially as India moves towards 175 gigawatt total renewable installed capacity. And given the intermittent nature of the renewables, especially the solar duck curve in the evening times, the ramping requirements becomes severe, especially when you compare that with the remaining resources that we have on the grid, which are thermal plants, which don't move that quickly in response to ramping requirements. And so ramping is, you call it resource adequacy, call it ramping, call it, there's a number of different things that you would call it. That's the second broad bucket that I would classify as being a big grid requirement. And then third is the biggest volume of energy storage that will be required in the coming 5 years and more and beyond will be the peak shifting aspect, which a couple of people have already alluded to. And that's what the RTC tenders are all about, which is basically taking the generation peak of the afternoon and shifting it to the demand peak, which is in the evening. And this is done not just for utilizing more and more renewable power, but also for the existing thermal units. These will quickly be suffering steadily decreasing CUFs or capacity utilization factors, as you can already see. And the CEA report that was put out on this predicted that this would go down to 26% at the rate at which, if nothing changes, and if we have 175 gigawatts by 22-23, that's a really alarming state of affairs for even the thermal industry. And so for all of these reasons, both for the increasing use of renewables as well as for sustainable continuance of the thermal generation, we will need energy storage resources that can move the peak from the afternoon generation peak to the evening demand peak. So these are broadly the applications. With regards to the second piece of your question around the challenges, I think the first challenge and the most important is something that Rahul very beautifully responded to, is the perception of energy storage and the discussion being centered around the cost or capex cost of energy storage, without really talking about what are the overall cost benefit analysis by application that you're considering for. Not all applications are equal, not all applications generate the same value, and you shouldn't treat energy storage as a one built-in cost and apply it across all applications. So really changing that perception of just talking about cost to going to doing a full cost benefit analysis and talking about what that is. And the second piece around that is really an improvement in the data available at the grid level, at nodal points on the grid, to analyze what the requirements are at any given point in that grid over the next 1, 2, 5, and in some countries it's done for the next 20 years. You've got integrated resource plans that happen in different countries for 20 years that are built from very granular data from the bottom up. Now, we need to start moving in that direction of the data is available. It's just being able to gather that in a central place and making it available to the industry to be able to do the analyses and come back and say, okay, here are the points in the grid that really have the most value for energy storage. And here's the cost benefit analysis. And then it's a straightforward discussion. It doesn't matter what the capex is as long as the cost benefit comes out positive.
So if that is an issue, what are the business models or economic models that could be deployed even today, right? Whatever the analysis we have and the data that we've studied, what do you suggest are, from a grid perspective, what are the kinds of business models that could be deployed? Where is it supposed to be located? Who owns it? Who operates it? How are the developers or owners compensated? Which models do you think will work going forward?
Yeah, I think there are a number of business models that you see around the world on this, beginning with the most prevalent at the grid scale, which is the generation coupled business model, where storage is coupled with generation at the generation point. There's the storage as standalone asset, where it is deployed anywhere on the grid, any point on the grid that you can have, in addition to the usual applications that I mentioned, you can have additional applications or additional value generated from the locational benefit of storage. So there are certain stressed points on the grid where you might be needing to upgrade the infrastructure or invest capex in relieving those stress points, where storage could come in and defer that investment at a fraction of the cost. And so there's the storage as a standalone business model as well. And then there's, at the grid scale, there's the storage as a merchant asset business model, which really relies on the presence of mature, deep markets around frequency regulation, around capacity, or even around energy, real-time markets. So these are typically markets that in the more developed countries, you see deep and provide a mature enough revenue stream for developers to factor those in and hence reduce the cost of the primary application of storage. So these are broadly the three business models at the grid stage. Obviously, as you go towards a more consumer level applications of storage, the business models would change dramatically. But I'd like to restrict my response to the grid scale piece. And then within that, I think the answer for India, in our view, is it will be a mix of all of the above, especially the generation coupled as well as the standalone storage model. Merchant model, yes, I think as our markets mature, as some of the markets that the CERC, et cetera, have planned are in the works, the frequency regulation, et cetera, come in, those will play an increasingly bigger role. But to begin with, I think we would do good by ourselves to consider both business models, both generation as coupled as well as standalone, which I don't feel is happening at the moment in our country. I feel like a lot of the attention is given to generation coupled models primarily because a substantial amount of the global deployment of storage has occurred under this model. And there's a very simple reason for that. Most of this deployment has happened in the US. And in the US, because of a freak of the way that they've designed their subsidy program, storage gets 30% capex subsidy if it is coupled with generation. And so you see a majority of the deployment in the US, the multi 100 megawatt applications that you see that announced in the US are primarily generation coupled for that very reason. But you see more and more the benefits of the standalone system and the additional benefits that it can gather, as I mentioned, from a locational benefits perspective, as well as from a dispatch perspective. There are a couple of advantages of having a standalone asset, both from a business model perspective, as well as from a location and value stacking benefit. I'll just mention three. One is, like I mentioned, the location benefits. You can locate it at whatever point on the grid generates maximum value and hence unlock additional value from the same storage asset. So that's one. Second is a broader stacking of multiple applications. When you have storage at coupled just at the generation level, you restrict yourself to the applications that would benefit or work in complement to the generators' requirements. Or if you, let's say, for example, do a DC coupling, which is generally another cost benefit of doing generation coupled storage, you then restrict it to your size of the inverter or the size of your connection POC. And the applications that you can do on that storage are limited then. When you have a standalone asset, it can be dispatched by a central entity like a load dispatch center, either at the state level, regional level, or national level. And that central dispatcher can stack on applications, multiple applications, much better than any individual party can for the maximum benefit of the system. And that also translates into a funding aspect where you can have a annuity model, which is a fixed tolling based agreement, where the dispatcher gets to use the storage asset as they see fit for whatever application they see fit within the parameters of a fixed tolling model. And then that on the financing side reduces the cost of financing as well, because once you start having a consistent, predictable revenue stream as opposed to a volume-based revenue stream for a storage asset, you reduce the risk of your cash flows in the future, hence reducing your cost of debt by as much as 100 basis points from our experience in the US. And that dramatically makes storage even more affordable for these applications.
Excellent point. I think you're absolutely right. The value of storage possibly lies in our ability to stack multiple utilities and applications for the same battery, right? I think if you're able to do that, the discussion on the cost will possibly change to the benefit, right? And then it'll be a much more favorable cost benefit analysis. Moving on from grid to, let's say, off grid, right? And Mr. Kushagra, and then you have a large experience in off-grid solutions. So tell us, what is your perspective in terms of major applications of battery storage technology for off-grid purposes, distributed energy storage, for example, right? What is the need of battery storage in such applications, and how do you think it will possibly benefit the end consumer? To what extent it will benefit, and where do you see the industry right now placed?
Thank you, Saurabh. Can you guys hear me?
Yeah, we can hear you.
Good. So I think let me start with a comment which Dr. Rahul has mentioned, that we are already seeing there are niche applications, including Andaman. In fact, we are working on a project across 4 islands in Lakshadweep, and those 4 islands are currently powered by diesel. And the cost, not only the government is subsidizing the transport cost of the diesel, but also the distribution cost of power from the diesel generation, how the power happens over there, or generation happens over there. So so across these 4 islands, we are not only installing solar, but also integrating storage along with diesel, and that power will be distributed, and the government will be, the investment is done by Solar Energy Corporation of India, and we are implementing the project, designing it and maintaining it for next 10 years, and underwriting the performance of the project. So those are the niche applications, and including looking at few projects in Andaman, and there are certain applications we are already looking in certain army bases, forward army bases, which are powered by diesel overall, and northeast in Himalayan terrain. And so there are already those type of applications where storage along with solar is already making a lot of sense. We are already seeing the storage cost coming down, as I think a few speakers have already mentioned about it. But what we are seeing is, as long as there are other technologies along with, in addition to NMC or LFP, there are certain chemistries from zinc are also coming in. Those can actually underwrite for more than 10 years, 15 years, 20 years. And so with those coming in and the price coming down, we see multiple applications coming in. So we are at the forefront of on the integration business, where we are understanding, looking at multiple technologies. We're looking at what is the end use of it, and then designing a solution around it. So as we have implemented multiple projects across 24 states in the country, so we are looking at those problem statements and picking up those projects, especially in, for example, Maharashtra, where the electricity tariffs are very, very high for certain commercial segment, in fact, more than 12 to 14 rupees in certain cases. So there are cases over there, it is making a lot of sense at today's cost levels. And if you project it out for a year, 2 years, not a 5-year plan. So we are already seeing that we can deploy in hundreds of megawatt hours these applications. So we are already now working out because we do a lot of PPA projects, own it on our own balance sheet, the commercial industrial application on the solar projects. So we are looking at few projects integrating storage and then offering it as on a PPA or a lease basis. So so there is a lot of innovation which is happening on the integration side of it when you understand from the systems perspective, and then plug it with the financial offerings which can come in. So and we're looking at batteries coming in from a 20-year design life perspective, right? And then there are multiple approaches how you design a system. And then there's a lot of innovation not only happening from a storage perspective, but on the inverter or PCU perspective as well, because how you drive more efficiencies out of the system. So from our perspective, we are seeing multiple niches are coming in, and already there are opportunities coming in. For example, as the country is moving towards time of day use, where the night power is cheaper than the daytime time. So there are a few clients of ours. They're asking, can you just install storage at our premises? We will charge our batteries from a lower tariff at the night time and then use it in the daytime onwards. So I think those type of opportunities are starting to come in, and we'll see more and more of those deployments will have to come in. And I think the utilities will have to get ready for what is coming in, because they have only seen what solar can do for them. I think they will have to look at from a perspective when the solar and storage comes along. I think we have to get ready for from that perspective as well.
No, that's right. And that's what we were getting at. We were discussing with Parimal ji earlier that we see some bit of application of storage at a large scale, anyways, right? And you've seen that bid from the government, where people had to participate using an energy storage and renewable power, right? So combination of these two, as and when it becomes completely equated with the grid at the cost there, I think it will see possibly a large application. Do you see, Kushagra, do you see a significant demand? So we are talking about a 50 gigawatt hour kind of a manufacturing space, and I will go to manufacturing in a little bit, but just sure. So you're here right now and you're saying there are a lot of niche applications that you're seeing and there's a lot of demand coming. Do you see a significant component of the battery storage in India, the application of that in these niche areas behind the meter kind of applications? Do you see a large component like a 20-30% of that coming in from these areas?
So I'll go with the data. Good question, actually. I'll go with the data again with Rahul mentioned that there is already a genset installed capacity of close to 80 to 100 gigawatts. And what we understand between 10 and 20 gigawatt is some mostly operational type of it. If you think about replacement of that, right? And so the number starts becoming making a lot of sense. And then if you plug it with your prices reaching between $120, $150 per kilowatt hour in next 2 to 3 years installed basis, then you're looking at a multiple fold jump. From a manufacturing perspective, achieving those kind of numbers are actually mind-boggling. But if you look at deep dive, this starts making sense. From our perspective, what we are seeing is there are clients which we are in a discussions, single installed base, 10 megawatt hour, 20 megawatt hour. So there are those niches which are starting to come in as single locations. But there are multiple of those we are currently under discussions, which are 1 megawatt hour, 2 megawatt hour, 3 megawatt hour discussions. So it has started to have that. And then you bring it as the industry or the financial industry has become comfortable financing solar PPAs, right? You will see once the financial industry starts becoming comfortable with the storage PPAs, you will see that numbers jumping very, very quickly. And we see that should start coming in another 2 to 3 years, because it has already started happening in developed markets, either in Europe or in US. And over there, the commercial PPAs are starting to happen. Utility scale PPAs are already happening on the storage piece of it. So the numbers are starting to make sense.
Very interesting. And if you look at the applications now, right, we're talking about grid storage, we're talking about off-grid and these niche behind the meter kind of applications. And one of the most important and possibly most widely talked about application is electric vehicles. So I'd like to bring in Mr. Gill and talk about some of the challenges. This has been talked about enough, but I would still like to understand his perspective on the challenges faced by the two-wheeler EV industry. What is the likely growth of this two-wheeler industry? And specifically speaking, do you see battery as a major playing a major role in these challenges, right? And what do you think will be the operating model when it comes to battery for a two-wheeler electric vehicle market to develop over the next few years?
Yeah, Saurabh, like we are all used to such a great petrol side motorcycles and scooters for the last 40 years now, that when you introduce electric vehicles and customers walks in, he likes performance which is similar to the one which he is used to in case of like a Hero Pleasure or an Activa or any other such vehicle, right?
Sure.
So that type of a performance, if we want to give it to electric vehicle, and one of our company, sister company, Hero, is trying to do for Ather, then that price becomes exorbitant for a customer, which is upwards of 1.3 lakhs or something. And although he likes the two-wheeler, but he doesn't buy any. The main part of that is also the battery, because as you go for a higher performance, 70 kilometers per hour, long range type of a vehicle, you need upwards of 3 kilowatt hour batteries over there in lithium, right? And the replacement cost, if he asks the question, it is so frightening for the customer that, okay, first time I will pay 130,000, but the next time I'll have to pay 60,000 rupees for a replacement cost of that, which is equal to the cost of an Activa. So it doesn't make sense for anybody to buy that type of a vehicle, even if there is a TCO intangible advantage, which in a way they don't calculate it the way we tell them. They say, if I buy for 70,000, I have another 70, 80,000 to take care of TCO advantage. Even the TCO is not there. Therefore, the time has not come for equal performing two-wheelers yet. And that's why most of the people have started coming down to mid-speed type of vehicles, which need much lesser batteries and which have lesser motor powers. But then there is a compromise between the performance, which is aspirant to the customer, and the actual on road. So these vehicles go at 40, 50 kilometers per hour, and they have a range of something like 50 kilometers. Although it fits well into Indian conditions, because road speeds are not more than 30, 40 kilometers per hour. And range required in a two-wheeler is not at all more than 30, 40 kilometers, especially with all the batteries being portable now with these two-wheelers. And they are 1.4 kilowatt hour battery weighing around 10 kgs, which can be okay with some difficulty carried home and charged like a mobile. So it fits very well into this. But if these vehicles today have to get a subsidy, then there is a limitation of eligibility of a range on them, which is 80 kilometers minimum. To give 80 kilometer, necessarily one has to put more number of batteries in that also in this 40 kilometer speed vehicle. And once you start putting higher capacity batteries, which is upwards of 2 kilowatt hour or something, the same effect sets in from a customer mindset. Okay, not 60,000, but I'll have to pay 40,000 for a replacement battery. So both these are sort of from a FAME point of view or a subsidy point of view, they are non-starters. That is why the net effect of that is we have seen in the last 1.5 years, the FAME 2 has totally collapsed and there has been no subsidy really. More than 16,000 vehicles have not been subsidized. So in case we are able to find a solution till the time battery prices come down, we have to find a solution of removing the range criteria from this and making it as a choice of customer. If you want a 40, 50 kilometer range, speed should be there, but the range can be reduced. Perhaps there will be an explosion of demand because the replacement cost of batteries will be then 25,000 or so, which is okay after 3 years. Another thing in the battery is, because as you go up higher in performance, obviously number of batteries go up or higher capacity go up, the cycle life is still predetermined from a user of a two-wheeler with the road condition and temperature conditions of a battery. So we are not talking of anything more than, for example, 1,000 cycle life on a practical road condition at a pack level. Now this 1,000 cycle is not understood by the customer. He says, give me number of years. And in number of years, nobody has a sort of a risk appetite to give more than a 3 years warranty on a battery. So imagine the customer thinks that in any case, after 3 years, I'll have to replace a battery costing 60,000. Why should I buy? Or if I'm not even getting a subsidy on a vehicle, why should I buy? So that's why we are caught into a vicious cycle where the volumes of subsidized vehicles have gone down and the volumes of non-subsidized vehicle, which are sort of 40 kilometers, 30 kilometers per hour, 50 kilometers, have dramatically increased. So it is against the policies of the government. So that's where we keep fighting with the government that if you want to really replace an electric two-wheeler, don't think of I am creating an equal performing two-wheeler. Think of the one which mobility solution is fulfilled by the customer, the road conditions ke hisab se, temperatures ke hisab se, give a battery which has a good life, which is not more than 30% of the cost of the vehicle. Then only it will explode, otherwise not.
Interesting. Also, from a consumer of batteries, right, as a procurer of batteries, what do you think, Mr. Gill? How critical is it to develop, a domestic manufacturing base? You talked about cost, right? And until we find a solution to the cost, it is the only thing that can work is possibly a subsidized environment where government supports it, and therefore possibly the demand can go up. But if you look at from a cost standpoint, is it critical to have a domestic ecosystem for manufacturing of these batteries? Will that help? How critical it is for us to have that?
So even if the cells are imported, and I guess they'll be still imported for at least 2 years, even with Niti Aayog pressing hard, it is very good and very critical to have localized batteries because of many reasons. The first one is because of the inventory carrying, that if you have an import batteries, you have to carry 3-4 months of inventories, which is wasting the life of the battery and reducing the warranty of the battery also. So that is the first needs over there. And also you're stocking batteries here, there, and at a dealer and everywhere, which means lots of lithium being stocked at a stationary level, not being used. Second thing is there are so many varieties of batteries in terms of size and configurations being demanded now by the customer, that it is impossible if you want to import 5 sizes, 6 configurations, and then couplers differently, and like Reliance saying I want this, and Amazon saying I want something else. So it's impossible for an importer to give so many variety of batteries. It is very easy for a local manufacturers to adapt to those changes. So it is very well understood that there has to be a pack manufacturer in India of good quality, and there are now some of them coming up like Exicom and Sun Mobility and Okaya, etc., who have started making good pack level batteries. But it is very, very important, because then you have to understand also the BMS part of it. You have to understand the way it is being used in the vehicle. And that cannot be just fit and finish type of a battery coming from China or Taiwan and put into our type of a temperature conditions. It will all bugger up. We have seen even vehicles exploding in India now. Why? Because we are just putting batteries from outside and putting it in India. We don't have mechanism of cooling properly, ventilating properly. So all these things means that you have to have a robust system, learn from here. Learning cycle itself is 2 years. So learn, start making batteries in India, assembling batteries in India, and thereafter, when you get cells in India, it will be a good equation for India.
That's good, and that leads us to the manufacturing ecosystem of the country. But before I go there, I would like to take some investors' perspective into this. Abhishek, you're one of the largest investors in the renewable space, right? Going back a little bit and talking about renewable from an investor standpoint, you are expecting significant growth. You already own a platform which has 650 megawatts of renewable energy. For the future growth of this platform and future growth, we are targeting at 450 gigawatts of renewable energy. How critical is the evolution of battery systems, storage systems in India from your standpoint? Second, also you're a global company, so I would like to hear your inputs on what is happening in the other parts of this world in terms of storage. We've seen countries which are very heavy. With the grid is very heavy on renewables. So how are they managing their ancillary services? Is there a large usage of storage there? And do we expect the same thing to happen here?
So thanks, Saurabh. Let me just answer your first question first. Yes, it's true that we are quite significantly invested in Indian renewable space, and we want to increase our exposure more. And renewable generation in India, as we all know, at some point of time would really need RTC or storage and different things than what it is now, which is plain vanilla solar, plain vanilla wind. So we expect batteries to come in a big way. And I've been listening to some of the other panelists here, all valid points. The fact of the matter is that batteries are extremely, extremely expensive, right? And as investors, we have, I mean, this is like a movie that we are seeing again, right? The same thing happened with solar. When solar started, because of government subsidies, tariffs of 15 rupees, now they're 2.5 rupees. Now it's great that the tariffs are now down to 2.5 rupees, but what happened to the PPAs that were signed at 7 rupees, 8 rupees, 5 rupees, or even 4.5 rupees? Like 4.5 rupee PPAs were prevalent 2 years back, right? And now we have people, wanting to renegotiate tariffs. So that is extremely cautious about. Battery, we know that right now it's expensive, but it will go down, as everybody believes that in the next 3-4 years it will go down. And once battery prices go down, obviously the tariffs that and at that point of time, what security we have are moving into the industry, grow and getting the batteries, well well installed in the country from the beginning. There's nothing, there's no benefit, there's only risk. That is what I see from now. The second point I want to make here is that, as Nishit, right now, if you want, and Mr. Parimal also mentioned earlier, that right now, if you go for a full RTC, it's extremely expensive. I mean, you mentioned 6 to 7 rupees, my calculation, so nothing below 8. That is extremely expensive, except for a certain class of customers who are already paying 11, 12, 13 rupees. But if you want to supply to those customers, there is again the regulator sitting in between, there is a DISCOM sitting in between, who has full flexibility to put whatever cross subsidy charges is that, and they can, do whatever they can, and the regulatory commissions may or may not rule in favor of them. But that's a huge regulatory risk that's faced even to supply to customers who see value in full battery operated plants today. So point I'm trying to make here is that either ways, I see a lot of regulatory risk in the battery space today. So unless somebody says that there is a policy, there is a framework in which the early movers in this space will be protected legally, it's very difficult for an investor like us to come in at this time. And I've also spoken to a few banks and lenders, and also very focused and very excited about this space. Some of the multilaterals also are very excited about this space, but all of them, end of the day, come to the same point that right now it's expensive. It will, when it falls, then what's the guarantee that we will that our contracts and our PPAs will be honored at that point in time? So that's the big concern that I'm looking forward that it will sort out in some time. On your other question about globally how we see this space growing, there are multiple business about standalone batteries as a merchant asset. There are multiple case studies. Companies came, companies grew, some of them survived, some of them didn't. So there is a business model that works even if you just take a battery asset. Now, if you can couple it with a grid, you can couple it with a generating platform, you can couple it at the customer's end. But the battery platform business model is there. It has been there, it will continue to be there. Depends upon how you have the ecosystem around it and how we have the regulatory framework around it. Some of the countries have a great network. I mean, there are microgrids working on batteries, hybrid battery enabled microgrids prevalent and coming up in a big way in US. You have IoT, etc., that are expected to become extremely successful, and we are seeing some of those opportunities, and we are looking at those. But we expect it's a great space. So we will continue to look at that very carefully going forward. So far, large-scale battery installations have been few and far between. Some of the other panelists have also mentioned, but they have been fair bit of success has been seen over there, and they will become useful case studies to see how things grow in the future. But I must say, from an Indian perspective, the regulatory framework and the policy around this aspect has to be much more stronger for all industry participants, not only just investors, but investors, lenders, manufacturers, developers, everybody, technology guys, everybody. They have to see value in coming in here and putting in their time and effort and making sure that they are protected at the end of the day before things. I'm going to stop there. Thanks.
So just a small input here. Very interestingly, so you said that there needs to be legal protection for the developers who are early movers, and we all know that one of the reasons why solar prices have possibly come down is because the ecosystem developed more and more demand was created, and therefore there was some economies of scale. Similar thing might happen here. What is your expectation from the government to provide this legal protection? What can be done? It is going to be there in the contracts, right? Even the PPAs that are being questioned today, legally they are valid contracts. They can't be challenged, right? So ultimately it'll end up being a legal battle. So what can the government do to prevent this situation in the future for battery storage? It's an excellent point. If we have a solution, that will be great.
No, so there are positive movements on that. I mean, the amendments to the Electricity Act that have been proposed, that's a huge part of the government which protects sanctity of contract. But as we know, each and every DISCOM is up in arms against those amendments, because for obvious reasons it takes away flexibility from their hands and puts the entire rights in the hand of a central authority. So they are all up in arms against that. But those kind of protections, and in fact, we see in some of the recent tenders as well, there are concepts like deemed generation, etc., that are coming in, which protect the developers and investors to a certain extent. But I would just be very bullish about the Electricity Act amendments that are being proposed by the central government. They go a long way in addressing concerns of the investors, and I would look forward to seeing them implemented. And in the same vein, the government also has to understand that battery storage may require certain other legal protections as well. Because frankly, I mean, as a battery, I mean, it's a portable unit, right? Why should I not be able to move that unit around depending upon the requirements of the case? Why should I be constrained on having the asset installed as a fixed asset while it's a flexible asset? You can move it around, you can use it in various ways. And once you have the flexibility, what kind of business models can be done and what kind of business models can be protected from a legal perspective. So I would say that there are positive movements, but it's a long way to go.
Got it. No, valid point. I think there are a lot of discussions going on the Electricity Act. As you rightly said, states are possibly not very happy with some of the provisions, especially around taking away their powers of putting or appointing commission members, etc. So yeah, hopefully I believe and I agree with you that the electricity amendment proposals provide a certain level of comfort to investors and developers, and if it is implemented and passed in the current form, I think it should go a long way to do that. So that's great. I just changing gears a little bit and going into manufacturing now, right? We have two large two manufacturers. One, Dr. Rashi, you're already manufacturing batteries in the country, and specifically lithium ion, if I'm not wrong. How do you see this whole space? Like, we've heard all the panelists talking about, yes, there is demand, there's going to be growth, there is possibly economic viability in some areas already. Government is very bullish on it, and I'm taking that factor out that government is bullish on it. But even if you talk to the industry, they are positive about it. Abhishek said that investors, apart from the protection that they need, they are also bullish. So how do you see this growth of domestic manufacturing in the near future? Two, what are the challenges so far you have seen in the manufacturing space, right? I mean, it is not simple. There are a lot of environmental issues around it, sourcing of raw materials, handling of raw materials, possibly, I don't know, also disposing of these batteries. So what are the kinds of challenges you've seen? Also from a talent and human resource availability standpoint, right? And what solutions do we have if this needs to move forward, if we have to see a gigawatt hour kind of an ecosystem, what needs to be done?
Okay. Yes, I have been hearing all my esteemed panelists here, and I agree with most of the points that each one of them have said here. Challenge. We were the pioneers in India to bring world's smartest lithium battery to India. So when I started with this, I had a tremendous amount of challenges in terms of making a consumer understand that what actually lithium battery is and how it is different from the conventional lead acid battery systems. That was the first challenge I faced. After that, yes, talent pooling was something which was certainly a big challenge. And even today, it is a big challenge because even though I see a lot of training institutions coming up like mushrooms around everywhere, but still the content and the quality and our academia and the institutions that we have are still not capable of delivering the right kind of manpower that we need. So academia industry collaboration has to improve. Industry has to come forward to handhold academia and devise more and more kind of programs to get all these people, because the minute we start the domestic manufacturing in the country, we will have a big requirement of this talented pool of young people that we need, and which though India has a lot of young population, but it is not trained and skilled for this particular segment as of now. So that's something needs to work. Second, with the supply chain, yes, we did face difficulties, and now there are certain hiccups at this point of time. But then I'm sure with the domestic manufacturing that the government is very pro for, would improve. But still, we need to improve on our sourcing. We need to understand that India. But then why do we have to just focus only on the cell manufacturing? Definitely, cell manufacturing is very important. But at the same time, we have a lot of ancillary and allied things which go into a lithium battery, which we can begin with. And by the time all the sourcing and supply chain is settled, we can start with the domestic manufacturing is what I foresee, to begin with, at least having a 75% make in India battery, at least made in India battery, something like that we can start with. I mean, I've been already doing this for like 5-6 years now. So I know these hiccups come on the way. Another big challenge that I have also observed is in the cell manufacturing, most of these companies hide out what is the environmental impact that they are doing. So we need to also understand that one side that we say that lithium batteries are very eco-friendly and they do not have any harmful substances, but at the same time, the manufacturing process needs to be evaluated thoroughly, and we need to understand that we are not impacting the environment in terms of water, in terms of air, and in terms of the other chemical pollutants that come out. Another aspect that I think India needs to ramp up is in the ecosystem is not just the manufacturing or the talent pool, but even the ecosystem to manage any kind of firefighting or any kind of hazard that would happen coming out of this, whether it is environmental, whether it is impacting people, or whether it is impacting even the energy storage for that matter from people. I mean, a very simple example would be that, some of the parts, I mean, with rooftop solar, we have had these issues wherein the monkeys come and they destroy the panels. I mean, many a times, no matter how much protection you do, still this kind of problems keep coming up. So they even destroy the wirings and the batteries and stuff around. So that is a bright possibility. So not just looking at the plain vanilla stuff. I mean, everybody needs some innovation. So India has so much of pool of talent everywhere. Can we come up with these small innovations also? I mean, this is also required. And these will give a lot of edge to our domestic manufacturing, because India is very unique. We cannot have something which we are directly getting from abroad and just fit it in. It will not fit into the piece that India is. India needs customization. We need customization for everything that we get in the country. I mean, like how Gil sir said that, the temperature is a problem, and on the road conditions, again, we just get 1,000 cycles and then the customer does not want to understand what 1,000 cycles is. So we need a lot of customization. We cannot have batteries, right, coming, just directly imported and fitted in, and you think everything is going to function well. That's not going to happen in India. You need a lot of customizations. You need to assess, and we need the right kind of talent today, which we have to develop from now on if we really want to have a sustainable and all-inclusive manufacturing ecosystem in India in the next 5 years at least.
Sorry, I'm sorry, I didn't realize I was on mute. So Rashi, what is your suggestion from a government policy standpoint, right? How can we do this? And I agree, we need innovation, and we have the right person in the panel today to talk about innovation. And I'm going to go to him next. But tell me, what is your expectation and suggestion for the government to make sure that this ecosystem talent pool is available? You'll be able to handle the customizations that we are talking about. How do they ensure that there is collaboration, not just between manufacturers and academicians, but also manufacturers and users today, like Mr. Gill, right, and academicians. So there is an approach which is more holistic. Mr. Gill can tell the manufacturers that, listen, this is the kind of customization we will need. You can tell the academicians that, listen, if that is what the consumer needs, you need to develop something that works here, right, and it is economically viable. So how does the government do that? What is your opinion on this?
Maybe a Skill India project because Skill India projects, there are many of them, even for solar skilling and stuff. So why not we have something for energy storage segment, and not just for batteries, even other energy storage segment, because each one of them in India would need, again, as I said, customizations and tailor made it to what India needs and how the customers are going to be. So that is one thing. Second is we did miss the electronics manufacturing bus, and now we're trying to again jump onto it. I don't think that's going to be happening. But then, like how IIT Mumbai has developed the cell manufacturing line, though it is still under labs testing, and we want looking at to get commercialized. But then we need to have some program by the government which involves the manufacturers, some part of the government agencies, maybe IITs or ITIs or diplomas, or maybe even private universities, and you could have a one particular segment of an just like how you have a course of mechatronics coming in, which has picked up recently. Something like that for storage can be devised with the industry consortium coming in, and that would really help even the students to come up. Right now, what another challenge that because I'm closely associated with many of the universities, and I see the students are being fooled because they don't know things, and they end up doing something wrong which is harmful to them also. Because if the battery burns or if something goes wrong, there's a fire hazard or anything, you will not be able to handle it with the kind of infrastructure that we have today. So maybe a program with completely involving industry, academia, and even industrial associations, because it would be easier for them to implement it through them, and that program could help. Right now, there are only a few private players, I think 4 or 5 private players who are trying to do these programs for the industry as well as academia on a small term basis. But as a full-time course, if it comes, that would help really a lot to us to develop a 5-year full program for domestic manufacturing.
Excellent. Yeah, I think I hope Kavita is listening. I think industry associations will have a role to play here to bring different kinds of industries together and develop this ecosystem. But going to Mr. Kulkarni now from SB Energy. Dr. Rashi talked about innovation that is required, right? We need customization in this country. Just picking up solutions overseas and trying to use those will not work. You are the man behind innovations with one of the largest institutions and investors in this world. Tell us what kinds of innovations the industry is spearheading at this point in time, and what should be the correct long-term approach towards this complete battery storage ecosystem, including all the talent, the raw material availability, the challenges that Dr. Rashi talked about in terms of handling a hazardous material, etc. Right? What is the right model going forward?
Yeah, thank you, Saurav. And I cannot agree more to Dr. Rashi. As she rightly pointed out, Indian conditions are very different, and this is not now. Right from when 25 years back I started with the R&D. We used to change almost all the products which are coming to India. At least 20-25% design changes are required to adopt to the Indian conditions. Specifically the ambient temperature. Generally, all the IEC rated products, they are rated for 40 degrees centigrade, and which doesn't work in India. Also on the second part, on the consortism, like for example, today Japan has come up specifically on the SSB, which is solid state technology, which we'll see very soon, maybe in the less than 5 years. So they form the consortism of all the big manufacturers, auto manufacturers and the battery manufacturers from Japan, and they want to push this way forward. I think we need to do something also for for Make in India and for the Indian technology. What I would like to do is, I would like to, in terms of potential, how big potential the storage has, I would like to correlate it, with the recent success of the telecom industry. As you see that there is a huge amount of investment coming in from the Google and Facebook in the telecom industry, and that's actually a good example, and probably we can learn from that industry. And there is a lot of similarities between that industry and the storage what we are talking about. So let's talk about they have a say technology layer. So there are actually six kind of a value streams or the layers. First is the technology layer. So where the mobile industry use like a ARM chipset or the Qualcomm chipsets. In storage, we talked about Dr. Rahul talked about also Nishit talked about it, that there are so many technologies which are spread into the storage space. The matured one are very few. When I say matured, like if you want to do a gigawatt hour of storage, probably the, only LFP, NMC, and vanadium and pump hydro. Maybe very few which can be counted on. On the other hand, the promising technologies which are kind of a commercialized, but still they are not yet to the scale what is required. Kind of a scale what we look at. And those includes the flow batteries, basically a zinc based, lot of technologies which are zinc based. Iron flow, interestingly, the iron flow technology has an reverse trend, where if the ambient temperature goes up, in fact the round trip efficiency goes up. But that's like a completely rare kind of a technology. uh, of course, everyone is looking at solid state as a next step. So that was the first layer. Second layer is on the telecom operator itself, and now in case of storage, it will be a developer and the investors, which will form that layer. The third layer is about the device, where in case of mobile operators, we have Samsung, LG, iPhone. Those are the devices. While in case of storage, we have a PCS, inverters, all the battery manufacturers, electrical vehicle manufacturers. Those will form that ecosystem of that equipment layer. Then if we go to the further, that is called as say OS, which is operating system. So we have, all of us know, like we have Android and iOS. In case of storage, we will have BMS and EMS, which is battery management system, energy management system, and also in case of EV, the kind of a charging management system. So those will form the OS for the battery storage. If we go to one step further, which is product and services. So in case of mobile, we have a lot of apps which develops, and we have Amazon app and a lot of other apps which works on top of it. And then similar thing is going to happen with the storage also. So many applications has been listed. There is a huge variety of applications, at least more than 50 of them, and each application we cannot use the same technology. So for each application, there has to be a unique combination of technology to achieve the lowest LCOS. So that application layer is also very, very huge. So if we look at it, like all the ancillary services, even in future, like vehicle to grid, and peer-to-peer connections, energy trading, basically demand supply, all those applications are going to emerge, which are not there today, but which will emerge in a very large way, and probably even more than what mobile operators have today. And the last but not least, the sixth layer is the infrastructure layer, where we have telecom towers and say cloud infrastructure, which are the major infrastructure for the telecom. In case of storage also, the grid and the transmission line infrastructure will be play very important role. And we call like a cloud computing. Now we have to call like a grid computing. After connecting so many resources to the grid, we need to have something very strong AI based, artificial intelligence based services which will emerge, which we need to have to manipulate what is happening on the grid, and how we can extract the right value from entire this all the six value chain, various equipments what we have installed. Coming to how the other technologies will impact, like for example, we have this TV earlier. Many of us does not have a smart TV. Now we get just Amazon Fire Stick, and it converts to the smart TV. Same thing is going to happen in the entire power industry also. Once now this 5G comes in, and we have a lot of reliable connection, internet connection, all the devices will basically become an IoT devices. That means they will directly communicate to the grid. So today, if I'm doing a, say, 250 megawatt power plant, today there is only one connection which is communicating to the grid, but in future, all the inverters independently will communicate to the grid. All the combiner boxes will independently communicate. Same thing is with the electrical vehicle. And then this particular, change will bring us a lot of opportunity and new business model. And in fact, it is so exciting to see that, in fact, I will not be surprised that this segment can pull more investment than even what telecom is pulling today. It is just a matter of time, and we will be there.
Very interesting, Mr. Kulkarni. Well, I also hope that we don't, this sector doesn't struggle the way the telecom sector is struggling at this point in time. But no, point taken. It's an interesting analogy between the two sectors. And what you're saying, if I got you right, is that different parts of this value chain will develop and will possibly have enough players and competitors in the market to make it economically viable and feasible, right? That is what.
Right. See, today what is happening? We are working in the pockets. The moment as Dr. Rashi told, we form the consortium and we look it from the ecosystem point of view. Then we will not think about a localized LCOS. Then we will think India as a country, how it should grow, and then there will be some plus and minuses in the segments, but then overall the segment will grow and it will fetch a lot of investments, and I will not be surprised that we will have our own technology, like we are claiming now that we have our own 5G. We should have our own battery technologies, which is the Indian make, and the investors will be eager to invest into that. It's just a matter of time.
Okay, nice. Taking a step back and talking about what Dr. Rathi also spoke about, and we have with us possibly the only potential lithium refiner in the country, Mr. Kalsi. You are getting into this ecosystem. I believe you've started the feasibility study to set up a large lithium refinery in partnership with an overseas company. So do you see, there are two questions that I have for you. One, what is the kind of demand that you estimate of lithium itself, right? Because of the various battery storage applications, etc. And overall, from a ecosystem standpoint, from the perspective of availability of raw materials, what is it currently? What are the challenges that you see in the future and roadblocks in the growth of this manufacturing? And I would also like to hear from you if you have a perspective on how the recycling and the reverse logistics might work in the battery industry, because one of the key extracts from that reverse logistics will possibly be also the lithium, right? And how do you recycle that? You will be refining lithium, you will be extracting lithium from overseas markets. You have a partner who will be mining it and sending it over. How does the recycling industry also work for you? So if you can give us a perspective on one, how's the demand going to be looking like, and do you think there is an ecosystem beyond just sourcing a raw material which you need? What kind of government support do you need, and then how does the recycling impact the kind of lithium refining that we're talking about here?
Thank you so much, Saurabh. I think I can start with saying that I agree with Dr. Rashi and Mr. Sohender Gill about the need for localizing minerals and the eco chain. Complete ecosystem is very critical for India as a country right now. If you talk about the demand for lithium in the next 5 to 10 years, I think as global adoption for battery storage technologies and EVs grow over the next 5 to 10 years, demand for lithium batteries will double every 5 years to reach an overall demand of about 2.2 million tons of LC. The LC is lithium carbonate equivalent by about 2030. And by 2030, use of lithium in terms of battery storage is forecasted to grow at a compounded annual growth rate of about 10%. If we talk about the overall global scenario of LC producing plants,
There are 38 operational plants as of now with a supply capacity of about 0.3 million tons. And going ahead in the future, there are plans to establish about 1.3 million tons of LC by 2030. So there are definitely, and which comprise about 107 projects, which are also some refineries under construction and some refineries going on in the future, planned in the future like ours. So there will always be a demand-supply mismatch between, as of now, the current situation says that there's going to be a demand-supply mismatch even till 2030. So if we do not today start investing in India as a country and corporates in the country start investing in raw materials and refining and technology, I think we'll be left behind by the other countries, because China, as everybody knows, has taken huge steps in terms of securing minerals as well as setting up refineries. Give an example, China has about 70% of the cobalt resources in the country, which they have already in the world, which they have already acquired, either directly or indirectly. And lithium, about 89% of lithium is refined in China as of now. Europe and the US are also making quick steps and trying to catch up pretty quickly. We in India, as of now, haven't done anything significantly important to move towards this ecosystem. But then I believe there's a government company called Kabil, which is taking some steps, and they have acquired some assets in Australia, etc. Also, the government of India has, done some tie-ups with companies with countries like Argentina, Australia, Bolivia. Some MOUs have been signed, which ensure that Indian companies and the government can get access to critical minerals in the future. Also, if you talk about the current Indian battery manufacturing ecosystem, it is primarily focused on assembling of batteries. Batteries are imported from countries like China, Hong Kong, and Vietnam. And out of a total of about $1.3 in imports last year, Chinese imports were about 800 million, and Hong Kong was about 300 million, and about 100 million from Vietnam. So here also predominantly we've been, being dominated by the Chinese. Globally, lithium-ion cell manufacturing, as I said, China, followed by US, Thailand, Germany, Sweden, Korea, they're all dominating this market as of now. The value chain, if we talk about the complete value chain of lithium, of the battery segment, so we talk about raw material processing, manufacturing of separators, cathodes, electrolytes, anode cell, and finally the battery storage packs. So with India only assembling battery storage packs right now and relying on Chinese imports for the rest, I think the aim should be to become self-sufficient across the value chain. So I also read an article a few days ago about India planning to import some tariffs on import of lithium-ion cells for the next 10 years, and offer incentive to boost local manufacturing as part of a broader effort to scale down reliance on imports. I feel it is a step in the right direction, but we should also parallelly take steps to boost domestic production, which I believe the government is doing through the 50 gigawatt battery manufacturing tenders. While India, has a clear policy with respect to the forward integration of projects and the finished product, we are yet to see a policy which, to promote manufacturing of components and also critical minerals like ours. So when you mentioned about what you're looking for from the government, what we want is that at least all the critical minerals be included in whatever policies are coming out in the future. The critical minerals be included in those policies immediately. So India, Indian battery is right now relying heavily on China, which we need to slowly move away from. So
please go ahead.
Just one more last point to add. So having, as I mentioned, that we're having a long-term supply agreement with countries which have mines like Argentina, Bolivia, Chile, and Australia. So it allows us to have a guaranteed supply of feedstock to produce critical minerals. Just to give an example, the whole purpose of moving towards EVs is to reduce the carbon footprint. So if we see it at this, for example, let us take the example of Tesla. Tesla, the mine is the material is the basic spodumene concentrate is stored in Australia, shipped to China, refined, and then shipped to America, and then again put into made into batteries and then shipped to Fremont in California to get put into cars. So there's a huge carbon footprint which we ultimately think we need to reduce. And if the sources of your materials are closer to the end consumers, that footprint goes down, and the whole purpose of doing this going electric gets resolved.
That's interesting. We have a couple of more minutes. So Jaspreet, I would also want to understand how will the reverse logistics, the recycling, the second use, etc. How will that work? Do we have the right supply chain setup, the logistics setup to make that happen? Because the disposal and the second use are going to be critical from this industry standpoint, right? And how does it specifically impact the refining aspect of lithium? Because you may be able to extract some lithium from the disposed batteries, right?
Right. So there are already a few companies in India, Attero, ZipTrax, who have heard of, who are into the refining of into recycling of lithium-ion batteries, and they're doing a pretty good job at it also, I must say. Especially Attero, I had a word with them a few days ago, and I came to know they're doing a pretty good job. So recycling today is about 20% of the total disposed battery worldwide. That is the benchmark. For recycling to slowly increase, I think that will be beneficial for countries like India. Urban mining is what we call it. If at all, we are able to increase the 20% to 30, 40, 50%, definitely it is going to help the country. Having said that, what effect will it have on our lithium refinery? Definitely the cost for recycling and the cost for producing it new should not be too different from the difference should not be too much. We are targeting a cost of under $10,000 per lithium per ton of lithium hydroxide, and I believe recycling also is about $7,000 to $8,000. So the differential is not pretty high. Plus, the recovery from recycled material is also the quality of the recycled material is also pretty good. So I don't see a challenge there. In fact, I see an opportunity along with the lithium refinery which we are putting. I think recycling should be encouraged, and definitely there is a draft policy which is already there. And if recycling is encouraged, I'm sure India can regulation for import of materials from outside have to be a little tweaked a little so that imports are allowed freely. So that we can import, if India doesn't have sufficient raw material to give its recyclers, we can import some from outside and then do it here, and then meet the demand, local demand.
Saurabh?
Yeah, very interesting. Kavita, I'm just wrapping up. I think Dr. Rashi Gupta has wants to add to this. Please, Mr.
On the second life, I'd like to add. See, most of these EV batteries are now going to come out, and you can use them for a non-critical stationary application. That would help us to still prolong the recycling, and India should not only look at only domestic manufacturing of cells, but at the same time we have to start a business model and an infrastructure for recycling, because whatever is being manufactured outside, we have the potential to recycle it. So we could eventually be in an ecosystem where we can balance out the need that we in the country have, also cater to the people abroad. So focusing not just on cell manufacturing, but even recycling infrastructure would be very helpful.
That's great. So that's great. We had a very good discussion here, gentlemen, ladies. I think my takeaway from the key takeaway from this discussion is that I'm feeling a lot more positive about this industry. The demand seems to be there. In fact, very heartening to hear that off-grid applications are also finding a lot of demand and use, not just the large-scale grid applications. It's Dr. Walwarkar's inputs in terms of actually we are reaching towards low-cost applications, and in some applications we are possibly economically feasible. There are areas like EV, etc., like Mr. Gill mentioned. We may need more government intervention before this can become completely, the large-scale adoption can go there. Some bit of consumer awareness, etc., some bit of financial instruments and structuring may be helpful. But I think there is some positive, progress there. Hopefully, government will look at this in a more positive light. It's also interesting to note that various technologies will possibly evolve and move together. and different applications will use different technologies. Hopefully at some point in time, all of them will become cost effective and useful. And lastly, the investor's perspective on how to protect investment in the future and not go down to the path that we have already seen in some other areas. So I think we collectively as a government, and as an association, maybe ASSOCHAM can play a role to provide some of these inputs to the government and see how we can take it forward. But thank you, everyone. Kavita, over to you, please.
Yeah, am I audible, Saurabh?
Yes, yes.
Okay, as we come to the end of this webinar, I would like to, on behalf of ASSOCHAM, would like to express heartfelt gratitude and sincere thanks to all the panelists for their intellectual contribution to this thought process. And of course, I would like to pay special thanks to Saurabh and Jayantji for joining us and moderating this session. In fact, we can assure you that ASSOCHAM will proactively work on this, and you can expect all the possible support from ASSOCHAM in taking each and every recommendation that you have taken. You have expressed, we will take it to the government. We will pursue aggressively with the government, and we'll see how we can position this at a strong platform for energy storage battery technologies. Saurabh, I would request all the panelists, in case if they could share their brief representations with us, which we will collate, and we will send a representation finally to the government. I would at the end also like to thank all the participants who have been listening to this, and in case if they have their inputs, they can also share it with ASSOCHAM at the email ID kavita.sharma@assocham.com. I, at the end, thank everyone once again for joining us. Thank you so much.
Thank you, Kavita. Thanks, everybody.
Thank you.
Thank you.
Thank you.
Thank you.